So people can see my screen now?
Yeah, we can able to
Yes,
see.
correct.
We can able to see.
Yeah.
All right, fine, fine. This topic is about electrical safety in substations and power transmission, energy, and solar projects in Middle East. So electrical safety, like I've been working in my complete career with substations in many countries. So I would take this topic and I can, I thought I can able to elaborate about this thing to my beloved colleagues and the students in William Engineering Colleges. And the second thing is about the projects in Middle East, like the future projects and upcoming projects and the running projects in the energy sectors and the power transmissions, their complete status and what is their future scope. So that is what I'm going to say in this presentation. So before going into that about COVID-19, we all know the COVID-19 has taken a complete jump over the global areas. Everyone has been stuck up in their places. Economy has came down, health has been came down, and people has been completely exhausted with their psychological, physical, and mental conditions. Of course, we know. So it is a time we have to be in a survival condition. We have to be healing ourselves, and of course, be aware and be more cautious. The things to be taken out from this COVID-19 and ensure you're not getting infected. And of course, we can't stop that. If someone of your loved ones or your people is getting infected, ensure they are getting your support, not a financial support, not a physical support, of course, the moral support. This moral support will encourage them to come out of this COVID-19. Of course, we are seeing many people who've been affected has been went into a fatal condition. So we don't want anyone to go into that condition. Of course, let us together survey about this COVID-19. It's all about me, myself, Tariq, as Malati Ma'am said. So presently, I'm working as a senior HSC advisor in Tractable NG. Tractable NG is an organization which is working globally all around the world, and the HQ is in Belgium, and we are taking care of the Middle East. Middle East in the sense like UAE, Qatar, Oman, Saudi Arabia, Kuwait, and Bahrain. So these are the operations which we are doing and the operations we are dealing with. And my present workplace is United Arab Emirates, Dubai. So I passed out in the year 2010 from VEC. So still along my college. Of course, I used to, whenever I come to India, sometimes I used to visit my college as well. And I visited last alumni also to my college. And this is my LinkedIn profile. So if someone want to be in contact with me, so you can go with this. And these are the countries I worked with. So India, KSA, Qatar, and UAE. So presently in UAE, and the projects I worked are in oil and gas with benzene and nitrogen. The major clients are SABIC and Aramco, one of the major government concerns in KSA, and substations in Qatar and Oman. So although my character, in my complete careers, I've been deal with like 22 substations, which I've recently commissioned in UAE also. And apart from that, I have also worked in a solar power plant, which is located in United Arab Emirates, Dubai, which is MBR, Al Maktoum Solar Power Plant, which is the independent solar power plant in Middle East, the first one, and which is has total 5 phases. So agenda about the program is electrical safety, health and safety, the substation power generation resources, how we are going to generate the power and where it has been starting and how it's been generated to the next sources, and about the GIS substation, which we are dealing with, which I'm working with. The flow of power loops and loop in and loop out of the substation chain. So each countries and each geographical conditions has their own cycle and zone graphics to have their own substations to be looped and looped out. So we're going to see about that as well. And about the substation equipments, process and safety measures in the equipment, about the operation and after the preventions. And power transmission, energy and solar projects in Middle East, as I said before. So it's going to be very clear that all these substations and all the things which I'm going to say after this one will be of Dubai Electricity and Water Authority substation standards. So it will be completely different from your own geographical conditions and your locations. So electrical hazards, of course, electricity, it's a necessary evil. So if you're going to work with electricity in a correct way, so we're going to have a good productivity. And if you're going to deal with in the wrong way, definitely the severity and the consequences more higher from minor to major, even fatal or death, we can say. So the list of electrical hazards impacts in the workplaces. which are burn, electrocution, shocks, arc, fire, and explosions. So burn, we can say small burn, first degree, second degree, and third degree burns. We can say it depends upon the severity and the consequence of the individuals is going to impact with. Electrocution, a person who has been completely accumulated conductivity of the electrocution of shocks, which results with fatal. And electrical shock, people may have a survival of this, but still the consequence will be more severe. Either the secondary effect might be a fracture or a second degree burn or a paralysis, we can say, or a spinal injuries, we can say, depends upon the severity and the consequences. Arc, fire, and explosions in most of the electrical activities or most of the electrical substations or the heavy mechanical works, we can say, arc, fire, explosion, the consequence will be higher and very severe. And of course, we are dealing this with every day in our workplaces. So the safety measures we are supposed to do is physical check, clear inspection, maintenance of the electrical equipments, machineries, and appliances before use. Of course, we are human beings. When you're going to deal with any equipments or appliances, we know a physical checkup, a physical view, a physical hand checkup. When you're going to handle, when you're going to see, you can able to identify any physical damages or during the operations, we can identify that the operation is not as before. So even though we know if it is not in a good condition, we are not supposed to work. If you're going to deal with that, definitely the consequence will be different. And as an engineering protections, ELCB and GFCI, the earth leak circuit breakers and ground fault circuit interrupters, I would have studied in your education systems as well. So ELCB is mostly used for 230 volts power supplies, and GFCI is mostly used for 110. So the countries where are working is UAE, Oman and Bahrain, they are using ELCB as a 220 volts, and in Saudi Arabia, in Qatar, they are using GFCI, ground fault circuit interrupters. And in most of the oil and gas plants, they are not using more than 110 watts power supply equipments. So mostly they are using GFCI, ground fault circuit interrupters. This is to identify any faulty currents, any leakages, or any overloads. It will be automatically tripping. This is the best engineering design control in a basic streamline, which can able to save lives. So the proper instructions and training for individuals to know how to and how not to handle the electrical equipments, this could save lives. So the maintenance, the usages, the handling, and of course training and supervision is most important. So check of equipments and cable and power ratings of any appliances on use. In our places, we used to do whenever we got a fuse out or when we got a power cut off, we used to have a small kind of wire to insert and to have a fuse to get our supply. That is absolutely bad practices because the load which we are going to accumulate in our house is not known by us. It is known by a competent person, so-called the electricians from the government authority. So they know what kind of fuse should be kept in there. So if you're going to give some low ratings or high ratings, that may affect all the appliances in your houses, or that may have an impact on you in case if you are on a contact of the fuses. So it is a absolutely bad practice. And use of PPE is personal protective equipment when you're going to use a specific task. It doesn't have any sense if you're going to have a cotton cloth to working with live appliances, no, not at all. Specific personal protective equipment that is going to help you in dealing with any tasks if you're going to have with work with any live appliances or electrical equipments. And finally, trained in firefighting, first aid, and emergency preparedness to handle situations on real-time scenarios, so-called the contingency plan. What if someone got electrocuted? What if someone got shocked? What if someone got injured and fainted on the spot? So what is the first step you're going to do? The person who's standing, he said, what are you going to do? You're going to touch him? You're going to save him? No, not at all. But you don't know what kind of impact that person has been imposed with. So if you're going to deal with him or if you're going to touch with him, who knows? You might also got electrocuted. So you should, or the individual should get the trainings and the mock drills to understand what kind of contingency that you're going to do, what kind of mock you're going to do when someone get infected or someone get electrocuted on the spot. So training is mandatory, it is necessary. Substation power generation resources. So this is a base chart that has been happening in UAE. So the main power generation resources here is gas, which was the initial one, and thermal, which was the basic one, and solar, which has been started before 5 years, and they're gonna use it for the reliable resources. And hydro plant is the first plant they're going to construct now. They're going to construct now, and it's an 8-year project. And hopefully, before 2030, they'll be constructing that one, which is in the Oman border. So these are the main resources that is giving the power generation for the substations. We can say the first level of power generation. The second level is 400 per 130 kV.
Sorry,
audio. Mute ஆயிடுச்சு போல் இருக்கு.
sorry to interrupt, Mohammed. Your mic is muted.
Sorry,
Just
your
unmute
mic has been muted.
Is it clear?
No. Yeah.
Yeah. Sorry. All right, fine. So, all right. So we are dealing with 130 by 11 kV substations for the end users, and the main power generation from the power plants to the 400 kV is being taken by OHL, overhead lines, and UG lines. But maximum 80% of the power transmission has been done by overhead lines from the power plants to the 400 kV. And the same vice versa is going to happen for the 400 to 130 kV. And from 130 kV to the end users, it's absolutely underground cables. So because for the robust and for the geographical conditions, they choose to have the underground cables for the end users usages. All right. So 130 kV by 11 kV GIS substation will act as a primary distribution medium from 400 kV substations as a focal endpoint users mainly routed from 130 kV. So the main users are the residential peoples, the commercial peoples, the industrial peoples, entertainments. So whoever has the requirements, they'll be conversing with DIVA, and DIVA will allocate a power substation accordingly for their conceptions. And this will be taken in case if they're going for different developers or the country development in the outside area, the same protocol has been followed. I have a different flowchart for how the 130 kV substation is rolling out, so that will be coming in the next coming slides. And the maximum equipments are from ABB, Alstom, and Siemens, and most of the equipments are approved from German. The substations are in line with the DIVA regulations, Bioelectricity and Water Authority, and a specification which will be completely inspected in each individual factories before deploying in the substations. So we have a Factory Inspection Act. So whichever contractor is going to develop this substation, they're going to go for the specific countries, so German, for each equipment, for transformers, for 11 kV switchgears, for capacitor banks, whatever it might be. So they will be traveling over there with the client, with the DIVA persons. They'll be inspecting the equipments, and whichever is approved, they will be coming for the substations. And all equipments manufactured with respect with IEC, International Electrotechnical Commission Standards, which is an external body aligned for manufacturing code of practice to be followed. And of course, this is also in line with the international code of practices, and of course in line with DIVA regulations as well. So GIS is a gas insulated substation. It's a normal practice in Gulf countries. Wherever I worked as of now, I have seen GIS. I haven't worked in India with substations, so I was not aware what kind of things they are doing there. But I heard that in India also they are exploring with some GIS substations now to have a safe procedures as well as to accumulate spaces in there. So SF6 gas is used as an insulation medium for 130 kV equipment, which is very reliable and safe for the equipment. So this has been initiated, and they are working with that. And SF6 gas is sulfur hexafluoride gas, which is colorless, odorless, and particularly a non-flammable greenhouse gas, which is an excellent electrical insulator. This has been recommended from most of the manufacturers, so-called ABB, Hitachi, and GE, General Electricals also. But the main concern is this gas is not human friendly. This needs to be handled in a very particular way, because this will be taken filled in a compressed gas cylinder, which will be installed, which will be initiated in the GIS equipment using a machine called DELO machine. With the accumulator pressure, it will be installed. But any kind of release of this gas or accumulation by the human being will maximum result with fatality. So the handling procedures and the initiating procedures will be done by a trained people from the manufacturer, whoever is giving the GIS equipment for us, or for the contractors, or for the clients, we can say. So loop in loop out connections of the substation. This is a basic requirements or the basic design by the authority. So they will be having a zone phase for each region, because UAE, Dubai is a vast places. where they are not planned to give a overload connection for all the areas. So if for example, if they have a substation, if they're going to give for 60, if they design for 60 people, it will be given only for 50 because 10 will be taken as a backup. So they will never give any kind of overloads for that. So whenever the requirement is high, they will be going for the new substations. So the first picture, we can say the substation ring connections. If, for example, if they have 5 or 6 substations, it will be interconnected. In case any failure of the substations will be given, the power supply will be shared for the other substations for time being. So the maintenance people will be having a backup time to repair or take a shutdown and to remake the things whatever happened in the wrong way. And so the new dot upside the ring connection, which is a new substation. So whenever a new substation is connected, if it is commissioned, it will be connected with the ring connection, the existing ring connection. So this is calculated like zone or phase, or depends upon the DEVA requirements. So they will be going for that. So no substation will be left idle. Everything will be connected in the ring connection of the phase and zones. So as I said, all substations are interconnected in the kind of ring shape to have a backup power. As such, failures of any substation shall be sustained with the shared energy. Above a typical picture, we have loops. So as I said, the loop in loop or substations. So this will be taken, the existing substation, the new substation will be looped out, will be given a loop in for the new substation, and that loop in will be given to the loop out for the other substation, so that it will be connected with the ring phase, we can say. So 130 kV GIS substation process flow chart. So this is the main real theory which I was trying to give it. So the loop in supply, so-called the supply from a 400 kV substation. So the first supply inlet will be, the feeder will be 130 kV GIS, which is the heart of the substation. So where the power will be taken, controlled, and which will be then carry over to 130 kV by 11 kV step-down transformers, where the power supply will be stepped down from 130 kV to 11 kV for the commercial uses. And from 11 kV transformers, it will be then transferred to the 11 kV switchgear, where the control will be there for taken for the direct end users, as we said, residential, commercial, industrial, or etc., whoever it might be. And Capacitor Bank has their own role to have the power factor and to stabilize the power supply of the 11 kV, whether it is to be eliminate or to add on the power factor, like the rating for UAE is 0.99, which we're going to see in the next coming slides, to maintain the power supply to avoid any kind of fluctuations. And earthing transformer is a feeder for LVAC room, and which is completely giving the power supply for the utilities in the power station, which is the small powers, CCTV cameras, AC supplies, access doors, and even for the pump rooms. So this ET is completely, the earthing transformer is completely the power supply for the substations, and 11 kV switchgear is the supply for complete end users. And coming back to, from the flow of LVAC room, the DC charger room. So DC charger will be giving the power supply for the battery. So the battery will be charging, and in case of any power failure or shutdown, the battery will be giving the supply for whole power substations only for the standby time. And the standby time will be approximately for 5 hours, which is the standard rating in all DEVA substations. Give me a minute. So this is 130 kV GIS equipment. The product which we are mostly using is ABB in UAE, mostly, but we also have GEs, and we had Alstom before, but there is no Alstom now. So we are dealing with ABB. So we have 2 bus bars in GIS, and each bus bar is being subsequently split into 3 parts. So we can say 135 and 246 that we're going to see in the next coming slides. So the above overhead EOT, electronic overhead tower crane. So that is the yellow part which you can able to see in the upside, the SWL and SMT, safe working load. So this EOT is used to install these equipments, and to even for the maintenance, and even to fill the gas. So this equipment will be using, and it can able to travel from the end to that end. So from either end, we can say. And complete equipment is earthed. We can see a copper earthing the ground area. So it is completely earthed, and we have signages, and we have fire extinguishers in each end. So in case of any kind of situations of fire, we can able to use the fire extinguisher to extinguish the fire. That is as a protective measures, we can say. And we have ducting systems to have inlet and outlet of the airflow in the substations, and the substation is completely of complete air conditions 24/7. And of course, the substation is a no-man substation, so no one will be allowed in the substation during the operations. So as I said, 130 kV GIS equipment plays a main role in substation, which inlets the power supply from external source. So we used to call as GIS the heart of the substation. So it acts as a control point for isolating of each component, the control of the amount of energy to be handled, transferred, and hold, finally to distribute the main channel, so-called the transformers. So once the GIS has been installed, so we have certain phase of testing 1, 2, 3, and the final commissioning testing. So the final commissioning testing is the high voltage testing, where we'll be injecting the high voltage power supply to identify any flaws or any power movements or any flashback is there. So once it has been done, then it will be going for the commissioning stage. So there is a usual pattern followed in all substations. So this GIS is designed with 2 bus bar, as I said before, with 3 subsequence of each. So 135 is 1 bus bar and 246 another bus bar. So before the sense like before a decade, so it was used only in a single pattern. But in case of flashover or in case of any kind of blast, so the consequence is more. It can able to damage the other equipments, the rooms, or people who are working by nearly. So what they have made is, as a design safety development, they distributed the bus bar into 3 different sequences so that they can have more productivity or more efficiency of output. And in case of any damages, only the subsequent part will be getting damaged and the other part will be saved. So here they will be saving the cost part as well as the safety part of as well as the development in the safety concerns that we can able to go for a better development on health and safety, we can say. Safety measures. The complete GIS is earthed, as I said. So earthing is mandatory. So they'll be having a step and touch to identify the earthing capacity. So all equipment, all handrails, all doors, everything is connected with the building earthings for the complete substations. So HVAC duct is available for the airflow in and out. As I said, they are also having a dampering system to get the ventilations of air inside and outside. This will be reduced. This will be used to avoid the dust reduction and to have an exhaust inside the room. And this will be shut off in case if there is a leak in SF6 gases. So as we know, SF6 gas is non-friendly gas. We can't able to exhaust the gas outside because that will affect the people who are working outside or whoever is surrounding in the surrounding environment. Sensors, alarms are available to monitor the room conditions, and specific fire extinguishers. Since it is an electrical substations, we used to have a DCP fire extinguisher, a dry chemical powder, and a CO2 carbon dioxide fire extinguishers. But these all are secondary as a backup. But the main extinguishing agent is nitrogen suppressions that we're going to see now. Sorry. The fire extinguishers in each exists, as I said, and the control indication to SCADA on any abnormal condition in GIS loop. If there is temperature is off, if there's kind of leakages, any flashovers, or any kind of abnormal conditions will be indicated with the motion sensors in SCADA, and this SCADA communication will be intimated to the headquarters in DIVA. So once it has been censored, they'll be sending an DIVA emergency team to identify what has went wrong, the maintenance team, we can see. So the final protection system used for fire suppression is nitrogen. As we all know, nitrogen is a cooling agent, so it is a killer of oxygen. So in case of fire, nitrogen will be suppressed there, and it will be killing the oxygen so that the fire can exhaust easily. Since this no-man substation, all systems is monitored remotely at DIVA main HQ, 24/7 and 365 days. As I said, it's a no-man substation. It is completely monitored with SCADA systems, and it is monitored in HQ of DIVA. This is the transformer. Again, it is an ABB product. We also had Alstom, we also had GE, and we also had a Hitachi transformers, which we are used in our previous substations in our previous countries, I can say. So this is a ABB product, an ABB transformer. This product is from, if I'm not wrong, it is from German. And we have a specific engineers from German, the manufacturer, who will be coming all through the country. And they'll be installing these equipments as per the design. And once it is the design is done, they'll be having an oil filtration. They'll be having a level of test from level 1 to 3, and then it will be commissioned for the rundown. So this is the process for IDT, and of course IDT is also earthed. and outside we can able to see this red pipes. So these all are the fire sprinkler systems and fire alarm indications. So the complete fire suppression system has been controlled by the pump rooms that we're going to see the next upcoming slides. And I think that's it with the transformers. And we have fire extinguishers outside the grill because this will be securely with a cage and it will be locked up. So unauthorized entry is not acceptable. Only authorized person for maintenance is acceptable. Of course, it's a DIVA protocol. So inter-distributor transformer IDT. The basic principle of transformer is to step down the voltage from 132 by 11 kV so that they can be transferred to 11 kV for the end user supply. Each substation has minimum 3 IDT, three transformers. It depends on the specific design approval from DIVA, if it is an industrial use or if it's going to be overload. So they can expand up to 4 and 5. And while in the designing stage, they will be having extra space, 1 or 2 for the IDT for the future expansions. So that is how they are designing as of now. And each transformer will be generating 60 MVA, megawatts amperes while step down process. The transformer oil inside the IDT, of course, we would have been studied in our college days as well. So this oil transformer is for good insulations and coolings, and this filtration process is to remove any sludge or dissolve or moisture in the gases. Of course, it is not recommended to have oil in non-purifications or in the moisture or any kind of gas formations. It is not healthy for the transformer in that condition. So it is not agreed, and even the manufacturer will not also allow. So this oil to have a long and consistent result for the transformers, of course, yes. Safety measures, as I said, the transformers are designed. I forgot to say about that. The transformer is designed the same amount of space. They have a pit below. So in case if there is a damage in transformer, the oil will be spilled in the pit, and it will not go outside. It will not have a spill outside. So in UAE, any oil spill or any environmental content will be having a heavy fine. So they have designed to have contained the oil in their own pit, so the oil will not go beyond the areas, we can say. All right. These transformers are designed to protect itself on any unforeseeable situations like reaching high temperatures beyond the threshold limits, because UAE, we have 2 climate conditions here. The 6 months will be having a peak summer and 6 months will be having peak winter. So this transformer is designed in such a way to sustain the outside temperatures, which will be reaching more than 52 degrees, 60 degrees Celsius in peak hours, and the internal temperature of the transformer, which will be reaching beyond 50. So these transformers are designed to maintain both the internal and external temperatures at the same time. So that is why we are having a best product in the country, we can say. The other protective measures such as high pressure water sprinklers, smokes, this is called the protective measures, we can say. And the internal design of the transformer, we used to say it's a preventive measures. The other protective measures such as high pressure water sprinklers, smoke and flame detectors, they will be having either smoke, either flame, depends upon the geographical conditions and the place the substation has been located. Because we have substations inside the countries, inside the states, inside the cities, and outside the countries, outside the cities, outside the place. So depends upon these areas, the flame or smoke detectors might be differs. And local alarm system is common. So this indication will be having an alarm sound to a radius of 2 to 3 kilometers, and the indications of SCADA will be given a communication to DIVA HQ on instant. And of course, specific fire extinguishers will be available, and any kind of indications, as I said, will be communicated to HQ. Apart from this, transformer is reachable with external fire hydrants for the firefighters to access on occasion of real-time fire. The external fire hydrant is placed at the distance of 5 meters in either directions of each IDT, the transformers, and another fire hydrant is available at the exit and at the entry of the substation. So in case of real-time scenarios, the DCD, the Dubai Civil Defense people, the firefighters, will be coming into the location and they can able to access the fire hydrant on instant to extinguish the fire. So there will be no time wasted when they want to extinguish the fire at the time of emergencies, we can say. This is the 11 kV switchgear room. The power supply is next way of path. From IDT, the supply will be given to 11 kV switchgear. And here you can see the people are working with the IDT. So this is our current substation which we are dealing with. This is going to commission in next coming, maybe in a couple of months, maybe December is the target. So this is the way, this is the final area of 11 kVs, the power supply to be coming out, and from here the supply will be transferred to the end users who is going to use it. As I said, the residential, the commercial, the whoever it might be is going to use it for. And of course, these substations, they have AC units, they have nitrogen suppression units, they have fire alarm systems, they have fire extinguishing systems, and they have an escape route in either rooms of 11 kV switchgears. And they have the, what I'm missing, fire extinguishers, alarm systems. Yeah, that's it. That's it. So the primary role of 11 kV switchgear is to intake the power from the step-down transformer, the IDT, and take it to the feeders via power cables. So that is the basic of this 11 kV switchgear to give the power supply for the inducers. And the major things which can't go wrong is the fire, blast, and flashovers. We might have seen in some videos also in WhatsApp and Facebook, which been circulating before. People who were working in the 11 kV switchgears, and suddenly they got a flashover and they got a flash and they got a blast. So because we are dealing with 11 kV, of course, it is not advisable, it is not recommended to work live. The equipment is on. Whenever they're going to have some maintenance, or whenever they have some regular maintenance or some kind of activities there, it's better to have a shutdown. It is better to have an isolation. Better to have a load or lockout, tagout. That will save life. Of course, the health and safety is only is there to not to save the materials, not to save the environmental. It is to save the people. That is the main agenda. And the production of the equipment is nitrogen. As I said, this room they have a nitrogen suppression in case things go wrong. And fire alarm sensors, fire extinguishers available on instant, and equipment fault notification will be communicated to DIVA HQ in case of unforeseeable situations. And of course, they will be having a CCTV cameras with 360 degrees to monitor all the rooms, all the edges, all the areas, nook and corners, we can say. This is a capacitor bank room. Capacitor bank is not easily accessible. It has a gauge, grill, access, and it also has an nitrogen suppression systems, and they have a specific kind of fire extinguishers. So here we recommend CO2, the carbon dioxide fire extinguishers, which is 5 kgs, will be placed in the exit. So we have 3 capacitor banks. Since we have 3 IDTs, since we have 3 ETs, we are having 3 capacitor banks here. Capacitor bank, as I said, the capacitor banks are used to control the level of voltage supplies to the end users by reducing or eliminating the voltage drops. So the travel path might have some kind of reduction, some kind of obstructions. The power supply may reduce or may get gained due to ionization. So more technically, this capacitor bank will use to stabilize the power supply, which is going to the which need to be come from the 11 kV to the end feeders, we can say. The cause of voltage drops might be due to the poor insulations, damaged damaged conductors, and even due to dust, silica dust, any dust it might be, which is less than 0.01 micron, it might be there. The process of the capacitor bank is to maintain the power factor to end users, and the PF rating is 0.99 as static in all DIVA substations. It is not in UAE, it is only for DIVA substations, they are maintaining 0.99. I'm not aware of the other substations, what kind of PF they are using for the capacitor bank. And the safety measures, the same thing as usual. The major hazards which can be accumulated in the capacitor banks are fire, blast, flashovers, and the other fire-related hazards. So of course we have nitrogen suppression systems, and of course the fire alarm sensors and fire extinguishers all over the areas. Earthing transformer. The feeder is IDT, the transformer. From transformer, the supply will be given to earthing transformer. And earthing transformer is the transformer which will be giving the supply for the complete substation utilities, for the small power lightnings, for the CCTV cameras, for the AC ducts, for the access points, for the pump rooms, etc. The substation will be run only with this transformer power supply. And there is 3 ETs, which will be the first picture we can see. The ETs will be completely secured, sealed, and will be locked. Unauthorized entry is not acceptable at all on any causes. Only authorized persons from DIVA, they have the keys and they have the authorities. Only with the permit they can access the ET. Earthing transformer, as I said, it's a feeder for using the utility powers recommended for the substations, which is for small powers. As I said, I don't want to repeat it again. And it is a step-down transformer which converts the incoming 11 kV from IDT to 400 watts for local utilizations. So this is another step down from here. And safety measures, which is this is in common with the transformer, as I said. So they also have a sprinkler system, and they also have a fire extinguishing system, and they also have an external fire hydrant system. So it's we can say as a step-by-step fire protection system. So if the sprinklers went wrong, so the sprinkler runtime will be giving the time for the firefighters to come and enter the areas to extinguish the fire extinguisher. So this is the first step is fire sprinkler systems, and second step we can say as fire hydrant systems, external hydrant systems. LVAC room, low voltage AC room. Sorry about the floor pictures because I didn't get any good picture about that. And this is on the live substation which I got from the substation. This system, they have the complete control utilities for the substations for all the lights and switches and etc. So they can able to control it here. And since it's a live substation, they have the LOTO, so-called lockout tagout. Let me explain about it. The lockout tagout is nothing but it's an isolation process. They're going to use it for in any kind of plants in the oil and gas plants or in the power plants, we can say. If someone is going to work with some kind of maintenance, if they're going to switch off the power supply, they'll be going to work in there. So it is required for the lockout tagout. Whenever they're switching off for the maintenance, they need to put a lock and a tag mentioning that the work is going on and this is the person who is working there, so that people will not come and access the area. What if happens if the lockout tagout is not here and the person has been switched off the plan and is going to work with there, the other person may not know who is working there, and if he's accidentally giving the supply on, we may not know what might happen to the person. He may be electrocuted, he may be shocked, he may be burned. We may not know. So this lockout tagout is mandatory for LVAC room, is as per the ZEVA requirement in line with standards, and there is no compromise about that. So LVAC room is a control room for the complete substation, as I said. Just keep on repeating, sorry for that. And the safety measures or possible hazards during the operations are fire, flashover, overload explosions, and other fire-related hazards. The room is fixed with dampering systems, and the dampering system, we know the power, the air inlet and air outlet. So the usage of the ventilating systems, we can say, with no power. For exhaustions, and heat sensors is available, and fire extinguishers available in each exit for easy handlings. And the main protection system used as a fire extinguishing agent is nitrogen, as I said before, as an extinguishing of project. Since LVAC panel is live, all equipments are placed with lockout tagout. This is used for the power isolation maintenance and for any shutdown process. DC charger room. The main purpose of DC charger room is to give supply for the battery. Simple as that. There is nothing more about it. Sorry. So this is the main purpose of it, and this will be giving a direct current for the batteries to get charged for the complete substation to give a backup supply. All right. So this charger is a feeder for the battery substation, as I said before, and in case something goes wrong, battery will be taking care of the supply, complete substations utilities. And the safety measures or the possible hazards might be fire, flashover, and fire-related hazards, as I said. The room is with fire sensors as usual, and the purging system is nitrogen. So battery room. Before going into battery room, I would like to share a case study which I was involved, one of the substations which I was involved in the activity. About battery, which is having two rooms, battery rooms. So each rooms has 180 cells. So 180, 180, 360 cells of each rooms. This battery will be assembled here. So distillated water will be filled here, and it will be charged and discharged here. The protocol is the process of working with battery is just 5 days. So first day they'll be charging the battery for 8 hours. Second day they'll be discharging it for 4 hours. Third day they'll be charging it for 8 hours. Fourth day they'll be discharging it for 4 hours, and the fifth day they'll be charging it for 8 hours, and the runtime starts. So that's it. That's the start of the battery. So what happened in the substation where I was working? This happened in Qatar. When the charging was ongoing, it was one Friday, and Friday is off here, so we are not supposed to work legally. And there were the two skilled laborers were given for this activity to monitor the temperature, because for the charging of 8 hours, people need to check for the temperature to identify the cell's healthiness. So they were they were notifying the temperature of each battery cells for every 1 hour once. So the activity starts around 10 o'clock and it was running around until 6 o'clock. So we all know that the charging of battery will exhaust hydrogen, and hydrogen is highly flammable gas. So what exactly happened was, while the charging was happening, these persons were not aware. They were taking the temperature while opening the cell. They're inserting the thermometer to identify the temperature. So after the last hour, after the 7th hour, 8th hour, when they are entering that one, they identify the room is completely boomed with white gases. They thought it was AC. And when I was using the thermometer to identify the temperature and scratched out the temperature with the cloth, with that static electricity, the oxygen got fired and they got blasted, and these two people got severely injured. One person with second degree burn and one person with third degree burn. And that was the case of that situation. And we got the complete team to identify the accident, and we investigate the accident. And the situation, what happened was, the exhaust was not working. The exhaust fan inside the battery room was not working. So if that was worked with, the hydrogen which was exposed during the charging might have went outside. So it was not went outside. The exhaust was not on. The hydrogen accumulated in the room with the static electricity. It got blasted. That was one of the remarkable incident of that substation, and the substation was completely closed for 45 days. And the people who were they are good after some times, some days, like the 50-20 days, they were good. But one person was in a third degree burn, which is very severe, which is very severe. And the company has to give the compensation for them. They have to get the insurance claim for them, and this has been recorded in legal legislation for the court. So company has to go for the court, and they have to submit the legislation concerns. And the cost mentioned about this thing has been went big, and the client informed that this is completely contractor's responsibility and they cannot bear the cost. So that has been also imposed there. So this is just because of single exhaust fan was not working. So this is where the health and safety is involved. So whenever we're going to start an activity, we need to identify the complete study, what is required, what is not required, and who's supposed to be work there, the skilled person, the competent persons, the person who know about the subject. If we are going to give some two people who can able to just do the writing thing, they cannot able to do what exactly they have to do. The output will be disaster. So that is what happened here. So I just want to share this case study with you because I personally was involved in this accident. So about the battery room, as I said, so universal usage of the battery is considered as an alternate backup power. Of course, we know battery is a backup that can be used for for the runtimes, we can say. So the runtime of the battery backup for the entire substation is 5 hours. This is common for all the substations. And the hazard involved is during the operations are hydraulic spillages or leakage from the batteries, fire hazards, and hydrogen exhaust from the battery charger. So exhaust is available in the battery room to have a rotation of non-stop airflow, so that while the charging of the battery, the hydrogen exhaust will be, the hydrogen exposed will be exhausted from the room, so it will be not contained inside. And additionally, they have a hydrogen sensor, alarm systems, and fire extinguishers available at the exit of each handlings and usages. Also, they have an eye watch there in case of accidental spillages of the eye, the hydrogen, the hydrolyte in the ice, so we can able to splash it over instantly to avoid any kind of injuries to our eyes, we can say. Okay. And this is nitrogen room. So this nitrogen room, this capacity of nitrogen room has the volume to accumulate all the rooms, GIS, battery rooms, LVAC room, control room, SCADA room at a time. So that that is the volume of capacity which is having in the nitrogen room. In case if they have a faulty in all rooms at a time, that this nitrogen content supply here can able to fulfill the requirement. And this is the fire pump room. The sprinkler system is completely controlled here, and fire pump room has 3 pumps here. One is jockey pump, one is electrical pump, another one is diesel pump. So jockey pump, all these pumps are connected for the delivery systems to have a sprinkler for supporting of transformers and for the ETs, we can say. Jockey pump will automatically run off in case of anything goes wrong with the transformers or IDTs or any other system which is interconnected. And in case jockey cause failure, electrical pumps will run over And in case there is a power supply is cut off, diesel pump will start over. So they have a separate diesel tank nearby. So that diesel will be giving a supply for the DG to run over for the water supply to not to get cut off during the emergency sprinkling systems. This is one of the best design here. So they have been developed. It depends upon the previous history's accidents and the future design developments of health and safety here. And of course, all the equipments are earthed. We can see copper earthing downside. All equipments here are earthed and grounded. So substations, additional information. All substation UAE is no man's substation, as I said. So no, once the substation is commissioned on the construction phase, no one is allowed to enter the substation until or unless it is necessary, or the maintenance people with adequate permits are required to enter the substation. And if there is any breaching, the substation is completely controlled with CCTV cameras, and they'll be liable with legal prosecutions and fines, and they'll be behind the bars. Any fire alarm indication shall be addressed within 5 minutes by DCD, which is Dubai Civil Defense, and DIVA emergency team. So any kind of fire which is in the substation of any zones or any loops, they'll be reaching the areas within 5 minutes. So that is the maximum time which has been given by the DCD. And the 5-pump room is a key water storage supply for all the lead system in the substations, which is operated in 3 different processes, as I said: jockey pump, electrical pump, and diesel pump. All pumps have the same potential of controlling water power supply for the sprinklers, but the sources are different. So all the pumps will do the same thing, but the power source for the pumps are different, as I said. The complete substation is earthed as per the component designed by DIVA approved organization, which connects all the equipments, doors, handles, gates, and any other connectivity. Not only the earthing, the civil phase, electrical phase, mechanical phase, plumbing phase, the fire hydrant phase, testing and commissioning phase, all the phases, the contractor should be approved by the DIVA, the Dubai Electricity and Water Authority. So without that, they cannot able to work in DIVA substations, and this will be verified in each stage of process, and even on the commissioning stage as well. And the lightning arrestor is placed at the roof of the substation, which is also connected to earthing link, as I said before. And a separate nitrogen room is available, as we seen in the before picture, the substation, for purging consideration as a protective measures. So nitrogen room is taken as a phase. But I would like to add one more information. This is about the Qatar substation, which I worked before. There in GI substation, they have FM200, which is called foam 200. So if there is a flash or fire, the FM200 foam will be completely accommodated with foam, so that the SF6 gas or the flash or the fire will not go out of the room. Considerably, FM200 is very costly compared to nitrogen. That is first thing. And the renovation of the FM200 will cost more compared to the nitrogen. So depending upon the cost ratios and the efficiency, they have converted from FM200 to nitrogen rooms. But still, FM200 is recommended for the server rooms, which is having a high potential of fires. Reliability study for substation is 60 days. Of course, we know what reliability study is. It's a time of failure rate versus time. So reliability study, we can use it for any equipments, any appliances, we can say. For example, we can take a mobile phone. We can say the mobile phone will stand for 5 years. But the new phone, initially we won't having any kind of problems. So it will be working very fine. Maybe we can have some shutdowns or some kind of faulties, which is very minor. So the initial time of a new mobile phone will give a very decreased failure rate. So you won't having more problems. So once the phone has been in a good shape, it will be having no issues for a certain period. Like say we can say like 3 years or 4 years. Once it has been reaching the expiry time, we'll be having a lot of problem with the mobile phone. Again, shutdowns, so volume issues, headphone issues, battery issues, etc., etc. That is due to the usages, the overchargings, or with dust accumulated, the handling systems, we can say. All right. So then the increased failure rate is done. We're going to throw the phone and we're going to get the new phone. The same thing is applicable for the substation as well. So they'll be having a reliability study for 60 days. to identify the runtime of the equipment. So the substation will be having have very minute failures in the initial stage. We can say like 0.5 to 0.8%. That was the ratio which is initially happened. And once it is done, the 60 days has been happened, they won't be having any issues for like 40 to 45 years of the substations. And once it has reached its expiry date, I forgot to say, the substation will run for 50 years. Once it is done in the expiry area, so we'll be having increased failure rates, some faults, some failures due to over usages, due to no usages, due to overloads, equipment's qualities, the poor connectivities, geographical conditions, etc. In a simple terms, we can say wear out and tear outs, the wears and tears. So there is the time the substation need to be demolished and they'll be going for a new substations. So this is all about the reliability study for the substations. And here we go for a substation 2. This is one of the substations which is recently commissioned in Diva network. It's just for your 2 here.
Almost all substations seems to be indoor type. Tariq?
Sir?
Almost all substations are indoor type.
Exactly, exactly.
Okay.
I hope the movie was good. So if anyone is planning to visit Dubai and they want to see the substation, you can contact me so I can take you for a real tour. No, I'm serious. I'm not joking. So you can come over here if you have a chance, and you can give a contact. You can contact me, and I can take you out. So I have that authority to take to my substation which I was working there. The next thing is the projects which is in the current phase and the projects which we are hoping for the future in Middle East. People are, of course, we know there is an economical lag now, and most of the people are out of jobs, and there is a lot of things are happening with stop of projects and stop of manufacturing productions and etc. etc. So it's a temporary concern because we cannot stop economy grow. You know, whatever happens is just a speed breaker. So of course there is a growth is there. We cannot stop economy, not at all, not at this time, because people are having more developments. The technology is improving, the productivity is improving, the demand is more. So once the demand is more, of course, we have to fulfill the demand. So don't get low about your education systems. Don't get low with upcoming surroundings, and don't get low about the information which you are gaining from the social medias or the unauthentic information. You know, so projects are there, future is there. Just we have to ensure that we are prepared for that or not. All right. So here we go. So I've worked in 3 countries here. One is Saudi Arabia, one is UAE, and one is Qatar. I'm okay with UAE. I don't want to go for any other countries. So the projects which we are going to see about these areas only, not Iraq. So don't worry, not Iraq. About Kuwait, Bahrain, Qatar, UAE, Oman, and Saudi Arabia. So this is called Middle East. We used to say Gulf countries, GCC. So in UAE, DIVA has in the last year, DIVA has sustained and planned to operate 85 substations for 3 years, and which is ongoing, which will be going to run for the next 2 years. And the 2021 DIVA has planned to deploy another phase of substations to be initiated for the development. So that is based on the 2021 Expo here. So it was supposed to be 2020 Expo. Due to the COVID, it has been transferred to 2021. And we are hoping for more substations to be coming out and more transmission lines to be coming out. And out of this 85 substations, we have 6 400 kVs. I would like to say like 130 kV substation construction phase to commissioning phase will take around 24 to 28 months. It is actually 32 months, but they are reduced to 24, 28 months. Still, it is depends upon the geographical conditions, the working locations of the contractors, and other stuffs as well. Sorry. And about this 400 kV substation, it will solidly go for like 4 to 5 years each substations, which is also including with the expansion and the small distributions as well. And there is one hydro power plant which is going to construct in the border of UAE, border of Dubai and Oman, which is the first hydro power plant which is going to construct in Middle East. So this hydro power plant, they have a very big hope. So they're going to construct a dam. They're going to construct a power plant there with a turbining system. They're going to generate the power. And with the line of this HPP, this hydro power plant, they're going to have maybe 2 or 3 400 kVs, which will be giving power supply to Oman, to UAE, and other region as well. So this is one of the biggest project, and they're going to plan to finish this before 2030. So there's a hope of 10 years project is there. And MBR is Mohammed bin Rashid Al Maktoum. He is the king of UAE, the vice president of UAE, and he's the ruler of. He's the head of military in UAE as well. So in his name, they have initiated this IPP, individual power plant for solar, which has already had 3 phases, and the 4th phase has just commissioned 2 months before, which is 950 megawatts, and they're going to constructing the 5th phase. They're going to start it from 2021. And it will be running for another 5 to 6 years project, and that is 850 megawatts. And this will be having connectivity of the phase 4 and phase 5, and phase 1 to 3 is different phases. This is also the vision of 2030. And Transco Abu Dhabi, transmission and distribution company. So Abu Dhabi has 2 electricity companies. One is Transco and one is ADDC. Transco will handle only 400 kVs, and ADDC will be doing 130 kVs. And one Transco has almost completed and they have completed around some 3. In that, one 400 kV was done by our company, and another 2 is ongoing, and another 4 to start up. So these things will give us hope that still, we have the productivity, we have the scope, we have the future for you peoples. So don't lose hope. So many other projects are ongoing still on the planning of SEWA, FIWA, and ADDC. As I say, UAE has 7 Emirates, and in that SEWA is Sharjah Electricity and Water Authority, FIWA is Federal Electricity and Water Authority, and ADDC is Abu Dhabi Distribution Company. So each region has each different departments. So each department has each different projects. So it's a wide range of power projects here. So we have a lot of things to grow here. And these are the renewable based generation projects in UAE. As I said, solar plant, they have the phase 4 now, which is supposed to be on 2030, and Baraka nuclear power plant, which is quite far away from Abu Dhabi, nearby to Yemen border. And this has been recently commissioned 2 months before, I believe, and they have planned for another phase also for this nuclear power plant. And of course, with all safety measures, because UAE is will start everything with health and safety, because safety is priority here, not about the productivity, not about any concerns. Health and safety is priority. So they have did the plant, and they have did everything in line with health and safety concerns. And Suyahan solar plant, which is Abu Dhabi solar again, and Ras Al Khaimah solar plant, which is taken care by FIWA. Another one is Hasian clean coal power plant, which is in the border of Ras Al Khaimah and Dubai, and of course Hatta power plant, which I said hydroelectric, and another coal station by FIWA. So all these have their certain periods: 2023, 2021, and 2022. So these are all the first phase. So once the first phase is successful, they'll be going for the next phase, and that will be will be taking another 3-4 years to complete it. So we have future projects also in UAE. And these are the projects in Oman. I don't know a list of the projects here, but the only thing to show the list of projects is to give you hope. We have these many projects here. So only thing is you have to be prepared to handle these things, as I say. And these are some of the list for 400 kVs and 120 kVs. And Oman is also a very big region. And Oman is now planning to have Sohar and other areas to have a big development in there. Once there is a development, of course, there's a requirement of power supply. Depends upon the development areas, the power supply will be expanding, the substations, the power plants, etc. So that's how it works out. And Qatar Electricity and Water Authority, Karama. I worked in Karama projects for 4 years, almost 4 years. I worked in phase 12 and phase 13 when I was there, and the phase 11 and phase 12, sorry. And phase 13 as begun and is ongoing, and phase 14 is in a primary stage. Each phase has each packages, and each packages has each substations. So phase 11 has like 8 package, and each package has around 10 to 12 substations, depends upon the working areas. So they have the substation packages, and they have the cable route packages as well to have the interconnection of the each substations. So once if there is a package is there, the productivity, the scope of work will be more. The substation connectivities, the ring chains, the cable activities, etc. So it's good. It's good. And Karam is also working on a solar power plant, which is not as big as MBR, but still they are working on it. They are on the trial process now. So once it is successful, they'll be having a next phase. It's an assumption, but definitely they will go for it. And Kuwait and Bahrain have not more exposure about Kuwait and Bahrain, but still they have more projects for power distributions. As Bahrain has recently identified a gas source, an oil and gas source, which they haven't been identified for past 2 decades. So they are on a revenue process, and they are on to a development of their country process now. So we are expecting, our organization is expecting more substations and power plants there in Bahrain very soon, from 2021 or 2022. But I'm telling about the initiation, the starting of the stage. So we have hope there as well. And Kuwait has its own line of substations. Of course, they're not stopping it because they are developing the country. Of course, they need the energy. And Kingdom of Saudi Arabia, we don't want to say. Kingdom of Saudi Arabia, one of the reputed project is Dubai Green, which we are the consultant for the project. And it has a desalination, and which has a combination of solar as well as gas as an renewable energy. And Kingdom of Saudi Arabia, the vision is to it is to complete it within the next 2 years. And what is their scope for creating this project is oil. Of course, their main resource is oil, but we don't know. Oil strategies may go up and down because oil is an global political economy. We cannot comment on that. But the country wants to have another more resources apart from the oil. If something goes wrong, if oil is stopped, they can depend on the power and energy sectors, and they can give a supply to all over the GCCs or all over the world if they require so. So the first step for that one is Dubai Green Project, which has dual resources, which is gas and solar power resources. And they have substations also. They have 60 substations in tender flow on last month, on this month 2020, 60 substations for KSA alone. So if they're going to start the tender now, the tendering will be flowing for next 2 months, and the projects will be awarded in first or second quarter of 2021. And the designing stage will start with the designing stage will start with 2021 second or third quarter or fourth quarter, and 2022 the project will be starting, and it will be running for another 2 or 3 years. So this is how the work will be going on. So the scope of energy is good. The scope of substation is good. It's all up to your hands, the young hands. I'm telling about the candidates who are in Valium Engineering College. So be competent, learn more things, be more competent, educate yourself, because openings are there, opportunities are there. People are not only getting the jobs by reference or recommendation. Of course, talents are also recommended. Talents are also identified. So make yourself talented. Be more strong with your knowledge, whatever it might be more strong. And of course, you will get more opportunities. Yeah. So if there is any questions, you can shoot out. I think I have taken 8 minutes extra. I'm sorry for that. So if there is any questions, you can shoot out.
Hello, Mohammed Tari.
Yeah.
Hello.
Yeah.
Yeah, I'm
Yes.
Balaji.
Yes, sir.
I have one doubt. In AI substation, we having like a circuit breaker, isolator, and other components. But in GI substation, don't have like that components.
No, it is there. It is there. But see, I'm not a GIS engineer. I'm a safety engineer guy. I'm not that technical about the GIS equipment, So I just got an overall, because if I want to say about electrical safety, I want to know about the operations. So I just take an outcome operations and I gave the safety precautions. That's it. So if there is a question, you can give it to me. I can get with the expertise and I will let you know about that.
Okay. Another one question. And normally in India, you're using AI substation. Why you not preferred GI substation in India?
In India, maybe about the cost, I can say.
Okay, cost.
Cost
Only
is
the cost?
more because see, Gulf countries, they doesn't care about the cost. They want the quality and the safety as a priority. So I think cost is the concern that they are not having more GIS in India.
Okay, thank you.
You're welcome. You're welcome. Any other questions? Anyone?
The participants, you can post your questions. If you have any clarifications, you can clarify it now, clear it now.
Or you can also give the questions to your staffs, and they can also give me a code, and I can give the answer for that. So I have no issues with that. Is there anything, or we can end the show? Yeah.
Right. I think they have a very good vision towards this one. So I think they have not having any doubts.
So it's good to hear. It's good to hear. Masud sir, that's Kek Mazar.
Yeah, nice presentation.
Thank you.
Thanks
sir. Thank
for virtual tour.
I'm happy that if you're coming to Dubai, kandipa nangal kootu poren sir. I have no issues with that.
Definitely.
Sure.
After
sure,
pandemic, let us plan.
Yeah, of course. Please.
Nice presentation. Good
Thank you,
read.
sir. Thank you.
All the best.
Thanks a lot, sir. Thank you. So I think it's good then. So we can end the show. Madhi ma'am, it's up to you.
Yeah, yes, sir. Yes, sir. Sir, HOD, sir, shall we end up the session, sir?
Okay.
Okay, sir. So, the esteemed speaker of today's event, Mr. Mohammed Tariq, has explained very clearly the safety measures in the substation. He has explained right from the describing the flowchart of the substation to various equipments involved in the substation like transformers, switchgears, capacitor banks, earthing transformers, etc. So particularly he has shared some pictures of fire pump room, battery room, etc. This is wonderful, and having a virtual substation tour is really a different experience for us. I think our participants have greatly enjoyed it. Mr. Muhammad Tariq has given a crystal clear explanation towards the safety measures involved in the transmission as well as the substation. I appreciate him and want to extend my sincere thanks to him for his valuable speech. Thank you, Mr. Muhammad Tariq. And it's my pleasure to thank our management, our principal, our vice principal, our HOD to motivate us to do this kind of knowledge sharing programs. I hope that the participants would have enjoyed the session very much. I thank the students, the faculty members for spending your, actually the faculty members from our college and as well as the other college have registered and our alumni as well as the faculty member from other colleges also attending. I took a privilege to thank him too for spending your valuable time in participating in this program. Once again, I thank Mr. Muhammad Tariq and thank you one and all. Thank you. Sir, before ending the session, we have a snap, please.
All right. Okay.
So the faculty members and the participants kindly turn on your video for a pic. Sir, HOD, sir. Kumresh, sir. Kumresh, sir.
சரி இளங்கோன் சார் எப்படி இருக்கீங்க?
நல்லா இருக்கும்பா.
சரி இந்த டிஷர்ட்லாம் போட்டுருந்தீங்களா? சின்ன பையன் மாதிரி இருந்தீங்க, டப்புன்னு கண்டுபிடிக்க முடியல. சாரி சார்.
ரொம்ப நாள் ஆச்சு.
ஆக்சுவலா ரொம்ப வருஷம் ஆச்சு சார். அலுமினி நான் எப்போ சார் 2017 வந்து நினைக்கிறேன் சார், அதுக்கப்புறமா வரல.
ஓ ஆமா ஆமா.
Fine sir, thank you. Thank you.
Sir, Tariq sir, can you turn off your presentation so that?
Oh, sorry. Is it okay?
Okay sir.
All right. குமரேசன் எப்படி இருக்கீங்க?
நல்லா இருக்கேன்.
நல்ல சூப்பரா காத்து விட்டீங்க, ஜாயின் பண்ணிட்டீங்க. சாரி.
ஓகே ஃபைன். பிரசன்டேஷன் சூப்பரா இருந்தது.
ஃபைன் thank you.
ஓகே thank you.
என்ன சார் இளங்கோன் சார்?
குமரேஷ் இருக்காரா?
ஆமா சார், அவர்தான் இனிஷியேட் பண்ணாரு, அவர்தான் கான்டாக்ட் பண்ணாரு என்ன.
ஓகே.
Sir, wait a minute, sir.
Yeah.
ஒரு போட்டோ எடுக்கிறீங்களா? நானும் எடுக்கிறேன். நீங்க எடுங்க சார். So kindly remain for few seconds, please. So thank you, sir.
All right.
Thank you, sir.
Fine. So where the presentation is like in concerns of health and safety, I will do that. Not an issue.
Sure, sir. Thank you so much for your invitation. Surely we will be make use of it.
Sure. Happy for that.
All the best, Tarik.
See you soon.
Bye. Kumaresh.
See you sir.
குமரேஷ் எங்க இருக்கீங்க? குமரேஷ் எங்க இருக்கீங்க இப்போ?
சார் இங்க காஞ்சிபுரம் அண்ணா யூனிவர்சிட்டி காலேஜ்.
ஓ ரைட். யா. ஓகே. எப்படி போயிட்டு இருக்கு?
போயிட்டு இருக்கு சார். பிஎஸ்சி படிக்கணும்.
சரி. ஓகேமா.
ஓகே.
Fine sir. See you. Take care. Thanks a lot.
Thank you, Tarik.